Hi, Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I would like to welcome IR Dr. Nani Fazlina binti Naim, Lecturer of Optical Communications, ECM715, and all the viewers to watch our video presentation. Before we start, our group members consist of two people, which is me, Muhammad Nazirul Naim bin Shanigapur, and Fangxing. So right now, in this video, we will present about the mini project that we have done on the title of optical communication system link by using the software in the computer called OptiSystem. So before we present the video presentation, we have done the report writing of the mini project. So this slide will tell on how our group members separate the tasks in order to complete the report. These also the things that we will present in this video. So as you can see, I have done the starting part and Fangxing have done the ending part. So what I have wrote in this report and what I gonna present in this video is the introduction part, where I will explain about what is BER, bit error rate, power budget, and component that have been involved in the system link, including their function. Next, the methodology of the report, and done the calculation in order to determine the value of power budget. Fangxing was done in writing discussion and conclusion. Uh, Also, me and Fangxing have worked together to discuss in choosing the component to changing its properties. So, what is bit error? How it's happened? So bit error is actually the noise, interference, or bit synchronization issue in data stream bits happen in communication channel. Therefore, bit error rate is the number of the bit error happen in the period of time, or number of bit error transfer in a specific time interval. This is important to get the value of the bit error rate, since it will show how accuracy the transmission of data communication line. Of course, it is a better for the communication system to have low value of bit error rate. For reducing, identify the cause of the error to improve the system. Now, power budget. Power budget is analyze power of the loss of a data link can be accepted from its input to its electronic loads. While maintaining the operation of the system, analyzation of the power budget is the important process to make sure receiver will have enough power to maintain its performance. To determine the power budget, we need to know the value of power output from transmitter and from receiver, where the power from source of transmitter minus the power required by the detector. So here you can see the formula in getting the value of power budget. As we require to design the optical communication system link via OptiSystem software in the computer, there are four parts that have been created in order to run this system. So for the first part is transmitter. Alright, transmitter can be defined as electronic device that able to generate radio wave or radio frequency that have been used to send the data. So four components that have been involved for making the complete transmitter is bit sequence generator, NZR generator, CW laser, and modulator. Type of bit sequence generator that have been used in this project is pseudo-random, where it will create binary sequence of the pseudo-random bit and also involved in determine BER value. Second, NRZ generator is function to generate pulse by producing a sequence of non-return to zero pulse coded. Next, CW laser or continuous wave laser to turn on and turn off the specific repetition rate. Last is modulator, where we use Mach Zehnder modulator to increase the frequency and control the amplitude of an optical wave. Next part is a communication channel. So, communication channel is the physical transmission medium. So, two types of the channel that have been involved in this system link is optical fiber and optical attenuator. So, optical fiber require to send light between the fiber to end. Compared with electrical cable, optical fiber can allow transmission over longer distance and higher data transfer rate. Next, optical attenuator is to decrease the optical power level of a signal or equalize the power level between two fiber. Uh, Alright, so next one is the receiver, or as this third part. So receiver used to detect incoming optical power and translate the analog or digital signal. First component for the receiver is pin photodiode that always used in order to reserve bias in the circuit. The other one component is low pass butterworth filter. This component will use to have as flat frequency response as possible in the pass band. Alright. So the last part of the system link is monitor or visualizer. So it is any of the component that will provide the reading of the desired value after run the complete circuit. Two components use Burr analyzer and optical power meter. Burr analyzer will estimate the value of bit error rate as required in the project. Next component is optical power meter, which is to provide the data of the power of the fiber optic or the optical signal passes through the fiber cable. Alright. Next part is methodology. So generally, what we have done to build up the circuit is there are three steps required in this mini project. So first thing first is by using the OptiSystem software, we have picked up all the components and arranged it. The picture above is the image of complete system link that we have done. After complete the circuit, we need to run and simulate this system. After the process complete, record all the data of the reading that show up at the component of Burr analyzer and optical power meter. Then, as required of this mini project, we need to make the modification of the properties in order to have low Burr value, bit error rate value. So here all the information and the changing that have been done. So optical fiber, we have changed length, reference wavelength, and attenuation value. The last modification is on the component of pin photodiode, where changing happen for its modulation bandwidth. So for this determination of the properties, me and Fangxing have made online meeting via Google Meet to discuss about it together. Alright, so last thing that I will present is the calculation in order to get the value of power budget. As the formula that have been stated, the power budget value comes from the subtraction of the receiver power from the transmit power. So this is the calculation. So our minimum transmit power is negative 3.254 and receiver power value is negative 13.254. So transmit power minus receiver power, and we got the value of power budget. So in this system, the power budget that we get is 10 decimal milliwatt. So I think that's all for me. And Fangxing will continue the presentation. Thank you.
Hello, my name is Fangxing. I'm from Fujian, China. This time, our mini project operation is to design an optical communication system line. Using OpSystem software, it is the first time for me to contact with this software. So I need to connect more information to understand the content of this software. According to the homework requirement released by the daughter, our team complete the experience report and record the video. Mini project with my partner Nazirul. We discuss the content and the division of labor of this mini project through an online meeting. This is an screenshot of our online meeting. They did draw driving imaging, writing code and missing storage and recording video. What I did was write a result and discussion, a conclusion, and record a video. We use the OpSystem simulation platform to build the free space optic BER analyzer. After the optical communication simulation platform is built, we need to optimize the attribute value of the component so that the output BER image will be least distorted. The output image is shown in the following figure. 3.3 Particle numerical optimization. In the FSO system, the visual rhythm bit sequence generator a visual rhythm binary sequence according to different operation model. The bit sequence is used to approximate the parameter of rhythm bit and output the binary bit sequence. CW laser continuous row laser generator a continuous rows CW optical single and output the particle single. When we try to modify the value of frequency and power in CW laser and compare the output image with the original imaging without modification, it is obvious that the distortion in the figure has changed. 3.4 Improve performance and respective BER. When we compare the output of the mini BER from the defect value of the optical fiber length 15 km with the modified one 10 km, we can notice that the value of BER has been reducing. Therefore, we can conclude that the lower the length view, the lower the BER value. When we compare the output of the mini BER from the default value of the reference wavelength 1550 mm with the modified 1000 mm, we can notice that the value of the BER has been reducing. Therefore, we can conclude that the lower the wavelength view, the lower the BER view. When we compare the output of the mini BER from the default value of the modulation bandwidth 2 GHz with the modified 1000 GHz, we can notice that the value of BER has been reducing. Therefore, we can conclude that the higher the bandwidth the value, the lower the BRV. 3.5 about the simulated platform case. The purpose of optical fiber communication experiment teaching is to master the base knowledge of optical fiber communication through particle design and to practice relates professional technical work after graduation. The overall design of the optical fiber communication is primarily on optical system simulation software for platform construction and simulation. We can then these scenarios of case operation by learning the base knowledge of software, mastering the base component of the component library by selecting different optical devices, setting the parameter of optical devices, and building different teaching case project of optical fiber communication experiment module. We can apply their theoretical knowledge to simulation design continuous thinking and improve model construction, analysis, and simulation. We can see, for example, list for 1. Theoretical basis and simulation of optical fiber transmission, and 2. Modulation and simulation of the laser device, and the 3. Principle and simulation of optical receiver, and 4. Optical fiber communication system and simulation, and another for the example. We can see contents of the experimental model project for this 1, 2, 3, and 4. This 1, 2, 3 project and this 1, 2, 3, 4, 5, 6 project. 3.6 implementation of the experimental platform. According to the requirement of the case designs of the optical fiber communication experiment teaching model project, combined with the relevant theoretical knowledge. Firstly, the simulation model is built according to the theoretical knowledge content model, and the experimental project is analyzing and designed by setting and modifying the component parameter for each experimental case project. There is a force. And we are through the design and simulation phase of the FSO communication system, the cooperation and the feasibility of the free spatial optical communication design system are verified. First, on using optical communication software to realize the connection of various functional modules, which provides the parasitic ability of the system. Optic system is an involving, continuously update and powerful optical communication design software that can design, test, and simulation It's probably design and planning from device to system level in optical communication system at the transport layer and into the present analyzing, review and design solution. Thank you very much.